so as promised, we are talking about angle, side angle, and angle, angle, side. As you can see, the acronyms here, ASA and AAS. Alright, so the first thing we need to talk about is angle, side angle, and just as a refresher, remember included means that it sits in between. It's like if you're having a conversation that includes someone, all three people are actively engaged in the conversation, and they kind of sit in a group of three. So these two angles here, and they're included side. Okay, if I have an angle, side angle, these two triangles are congruent. Two pairs of congruent angles and a pair of congruent sides that are included. Now notice the difference in these pictures. This time, instead of saying an included angle, I'm saying the non-included angle. So this would be angle, angle, side. This is where a lot of people get tripped up because the word non-included and the word included. A lot of people will switch these two. So it's very important that you understand that angle, side, angle. The side is in between the two angles in the name, therefore the side must be in between the two angles. It must be included in the conversation. Here in angle, angle, side, we have a conversation with angle and angle, but side's over here going, hey guys, how's it going? Third wheel awkwardness happening here, okay? So the side is not in between the two angles in angle, angle, side. It's off to the side, okay? Alright, so here is example number 1. We need to determine if we can prove that the two triangles are congruent and state whether or not there's enough information. Okay, first off, we know that angle EGH and EGF are congruent because they are right angles. That would be the definition of right angles. So angle EGH and angle EGF. Okay, so that's just the definition of right angles. We also know that EG is congruent to itself by the reflexive property. I am congruent to myself. Alright, so this currently is not enough information to prove it, okay? Right now, all I have is one pair of angles and one pair of congruent sides. I either need another side or another angle, and I don't have that. So this would be not enough information. Example number 2, in addition to the angles that are measured, so we have that this angle here and this angle here are congruent to each other, and this is my second pair of congruent angles here. In addition to what's marked in the diagram, we know that RQ is congruent to itself by the reflexive property. So therefore, we have two pairs of corresponding angles and one pair of corresponding sides. Now, I have a choice. I can do either angle, angle, side, or angle, side, angle. These are the only two that we know of that have two pairs of angles and one pair of congruent sides. So the question is the side in between the two angles over here, or is it out here third wheeling it, not having a conversation? Okay, so looking at this, I have angle, side, angle. This side is included in between the two angles, therefore I would say the angle, side, angle congruent postulate. So therefore I can prove that triangle PQR is congruent to triangle, and remember naming is important, so SRQ. Okay? Alright, 2-column proof. I'm asking you to prove that triangle WYZ is congruent to ZXW. Okay, first off, we know that something is congruent, that would be angle Y and angle X. So angle Y is congruent to angle X. And I also know that WY, oops, said W and wrote X, weird. WY is parallel to XZ. Alright, now it says by the alternate interior angle theorem, I know that two different angles must be congruent. Well, which angles are it? Let's see. If I want to extend these lines, that way it looks more like my parallel line there. And then I want to copy that to there. Alright, so these are my parallel lines. And that means that WZ is my transversal. So this angle here and this angle here are what we call alternate interior angles. So that would be, and we need to be careful about naming this, it's not angle W, because angle W is this whole angle. I only want this little piece of it. So that would be angle YWZ is congruent to angle XZW. No, yes. Alright, and then by the reflexive property of congruence, I know that WZ is congruent to itself. Both triangles share it, so they are congruent. I'll delete these out of the way. And taking a look at the triangle, I have two pairs of angles and one pair of sides. So it's either going to be angle, angle, side, or angle, side, angle. Now the question is this side in between the two pairs of congruent angles? The answer is no. Okay, it's not included, so we have to use the angle, angle, side congruence postulate, and that would be that triangle WYZ is congruent to triangle ZXW. Okay, let me verify W and Z, then to Y and Z to X and W. Yes, so I have named them correctly. It's very, very, very important that you name them correctly, because remember, the order explains what pairs of corresponding sides and corresponding angles are congruent. Okay? Alright, number 3, we have two triangles here. First off, I noticed that it's got it in 2-column format, so let's go ahead and state our given. First thing that we're given is that angle Q and angle S are right angles. I'm also given that angle PRQ is congruent to angle TRS. And one last piece of information you may have missed is that R is the midpoint of QS. So I just rewrite that. R is the midpoint of QS. And all of that there is given. Alright, with that information, what I can say is that angle Q must be congruent to angle S. And the reason for that is that they're both right angles, their measures are the same, so I would put definition of right angles. Alright, so slide down a little bit more there. Alright, number 3. Okay, what do I know about the midpoint? Okay, the midpoint cuts it into 2 equal pieces, so that means that QR and RS must be congruent in length. So QR is congruent to SR, and that was the definition of a midpoint. Now notice that I'm putting my markings here on the diagram. Excuse me. This actually helps me see what I'm looking at. So first off, I know I have 2 pairs of congruent angles and 1 pair of congruent sides, which means I'm either going to be angle, angle, side, or angle, side, angle. And in this case, the side is included in between the 2 angles, so therefore I can say the 2 triangles are congruent by the angle, side, angle congruence postulate. So triangle QRP is congruent to triangle SRT. So just verify that's written correctly. Q and S are congruent, yes. Okay, are QR and S are congruent in length, yes, so that leaves P and T. So we have correctly named this. Alright, well that's the end of angle, side, angle, and angle, angle, side. Tomorrow we will discuss hypotenuse leg. See you later.